Hello. Okay. Okay. Is it okay? So now you know already how to So you know already how to generate an STL file, and also how to eliminate the small islands using the mask flood fill. Okay? So the process is actually very easy. So it depends on the image data that you have. Okay, the process that I have shown to you might work for your image data, might not work for your image data. So it depends on the image data that you have. So I just summarize what we have done just now. So basically what we have done, to do the segmentation, we use a threshold button and then we define the range of the grayscale value, and then we create the mask one. And then we notify that we have a small islands. So to eliminate the small islands, we use mask flood fill, right? And then we click on the form, and then we eliminate the small islands. And then we create a surface model here, and then we drag the mask into the surface model, and then we click on full model, and then it generates for us the mesh. And then we click on export to export the STL file. Okay, right now we want to create the mesh for FE and CFD software. Okay, the mesh for FE and CFD software. This one is mesh for STL file. Okay, it's different. So this one is FE mesh, finite element mesh. Alright. So to generate the finite element mesh, it's the same process. You generate the 3D model, and then you go to home button and click on new FE model. Okay, go to the home tab, click on new FE model. So when you click on new FE model, you can see in your dataset browser on the left, at the bottom left of your screen, in the dataset browser there's a model 2 FE. Alright, so it's the same thing that we need to do, drag the mask into the model 2 FE. Okay, select model 2 FE. You can see when you select the model 2 FE, on your tabs, there's a new FE model tab. So you can select the FE model tab. If you select the model 1 surface, you can see there's a surface model here, it changed to surface model. So you need to select the model 2 FE in order for us to see the FE model tab. Alright? Okay, so in FE model tab is where we define the configuration of the mesh. Okay, so are you familiar with the FEA or CFD simulation software? Are you guys familiar with this meshing process? Anyone here use FEA or CFD software? 1, 2, 3. So meshing is the others will use. Okay, it's okay. So meshing is a most tedious and also most important task when we set up a simulation. So it will determine the resolution of your result. So if the mesh is coarse, is big, if the resolution is big, then which means that your result will be, the resolution of your result also will become big. Okay? So, and also during the meshing for finite elements, we need to define the nodes, we need to define the material properties, etc. I will show you later also what this is. Alright, so but then with the default configuration of the mesh, we can actually simply generate the mesh. Okay, so if you click on full model, it will generate the mesh using the default setting that they have. So if you want to modify the setting of the mesh, you can click on setup model. Okay, so we can see that the model 2 is the model is a model 2, which is the FE. The model type is the FE model. So the export type is abacus. So this one you can select any export type that you want. So it depends on your FEA or CFD simulation that you use. So you can see there are many FEA and CFD software: Abacus, ANSYS, Console, LS, Vina, matlab, etc. So you can export the mesh into your FE or CFD software. Okay. So there are several tabs. So I suppose for those who have used CFD or FEA software, it should be look familiar to you guys. But then for those who never use a FEA or CFD software, it might, yeah. These actually are the things that you need to understand. You need to define when you're setting up a mesh for finite element analysis. So for general, we always select the use smart mask smoothing. Alright? And then for the volume meshing, there are two types of mesh. It's either we can use a FE grid or FE free, but then it's always recommended to use a FE free because it's more flexible. And then the element type that we have in FE free is all tetrahedra. Okay, so for this one, this is where we define the size of the elements. Okay, so if we define here as equal to 0, okay, if we define here equal to 0, okay, you can actually always open the option by click on this more options button. Okay, click on this more options button, it will allow you to define, to see in details about the size of elements. So the size of elements is defined based on this, what is it called? Cursor, okay, based on this option. So you can select from -50 to 50. So if we select 0, the resolution of the mesh will be the same as the resolution of our image. So right now the size of pixel, I'm not sure the size of pixel is how much, but then if we select here 0, the size of elements will be equal to the size of pixels. Alright? So by default it is -25, so we just use by default. So you can see when we modify the coarseness of the size of elements, here the minimum edge length and also the maximum edge length will change. So example here, the minimum edge length is 0.00675, so which means that our pixel size, okay. So if we change this, the minimum edge length and the maximum edge length also will change. So as example, if I make a -1, is 0.001. So which means that our size of pixel is around 0.001. Okay. So we just change to -25 by default. Alright. And then so we have also another options like FE grid. So FE grid, the mesh is more organized compared to the FE free. So FE free is more flexible. So you have, okay. So for now, for this exercise, we will select FE grid, okay? And then for the materials, we just select homogeneous. And I think in the cheat sheet, you can find the value for the mass density, Young modulus, and also Poisson ratio. On the next page, you can see the cheat sheet on it. Page number 5. So on the page number 5, you can see the cheat sheet for this exercise. I'm sorry. Yeah, it starts from number 4, and then for this, yes, exercise 1.3. and then you can go to materials, you can find the mass density. Where is it? This one is the one that you can actually find the exercise. This one is yeah. So the Young modulus is 2.1 exponential 8. So the Poisson ratio is 2 exponential -1. Alright. Okay, so the rest we will exploit later in the second exercise. Okay, for now, to save all the configuration that we have made, we just simply click close button. Alright, and now go to the FE model and click on full model. Alright. Okay, so the mesh that we have right now is the mesh that we have generated using the FE mesh. Okay, so maybe if it's interesting, so you can see because it's a triangular mesh, so the mesh is still in triangular. So if you want to generate another type of mesh, you can go to setup model, go to volume meshing, and then, oh, this is a mixed hexahedra, tetrahedra, so you should be able to see the mix of hexahedra and tetrahedra. Okay. Yeah, so I can find it. Okay, here you can see we have a mix of hexahedra and also tetrahedra. Alright, here we have a triangular mesh and also a rectangular mesh. Okay? Is it okay? Alright. So let's say if you want to do a CFD analysis around, flow analysis around this form. Okay, so we need to create CFD mesh. Alright, so if let's say if you want, so in order for us to create the flow, to create the CFD mesh around the form, we need to create the model of the air first. Okay, to create the model of the air is simple, is the same as I have shown to you just now. You just go to the image processing. So right now we are doing the exercise 1.4. Go to the image processing, click on mask flat fill. Okay, make sure the target, the source is a mask, so you click on the mask 1, make sure it's active. So the source will become active mask 1. The operation is flat fill, mode is 3D, apply on slices. And then for the output, you select new mask. Okay, and then you select the black part. Okay, don't select the red part, but select the black part. Alright, so you can see that there is a new mask has been generated. Okay, so this is the air around the foam, okay, that you have generated just now. So we will use this model to generate the CFD mesh. Is it okay? Okay, I repeat again. Select mask flood fill. Okay, so firstly we need to make sure the source is correct. The source is the mask 1, the red color here. Okay, the red color here. And then the operation is flood fill, the mode is 3D, apply on all slices, output is a new mask. And then you select, you click on the void, on the background. Don't select the red one, select the black one. Alright, so once you select that one, you will generate the model of your air. Okay, so and then we will use this model to generate the CFD mesh. So you can see in the 3D model, we have the air. So if you click on the eye beside the mask 1 button, then your model will become like a porous media, which means we have a porosity. So if you can see in detail inside it. Okay? Alright, so we will use this model to generate the CFD mesh. So it's the same process. You just need to go to the Home tab, new FE model, new CFD model. So the new model 3 CFD has appeared here. Then you drag mask 2 into your model 3. Alright, and then go to the CFD model tab and click on setup model, and then make sure the model type is CFD. Then the export type, you can select whatever you want, depends on the simulation software that you use. Okay, you can be Abacus, Fluent, etc. And then go to general. As always, I will recommend you to always stick to the use smart mask smoothing. Then the volume meshing, we select differently this time we select FE free. And then, okay, we will define the material types. We will define as fluid. Okay, so the mask that we have created just now, the model that we have created is a fluid. Okay, because we want to do a CFD simulation. CFD is computational fluid dynamics, it's a fluid. Okay, it's a flow. We want to study a flow around the foam. Alright, and then we need to define the boundary conditions. So as you can find the cheat sheet, you go to the boundary conditions tab. From okay, it's a mask 2, sorry. It's mask 2, actually okay, the mask 2 is an air, so it's a fluid. And then we click to boundary Z-min. And then click on add boundary, and then select the boundary that we have created, and boundary condition type is velocity inlet. So it means that the fluid or the water or no, the air will come from the bottom, from the Z-min. Okay? So if you want to create another boundary at the top, let's say at the top, so just from mask to boundary Z max, click on add boundary, then the new boundary will be created, select the boundary, and then you select boundary condition type as pressure outlet. So it means the inlet will be at the Z min and the outlet will be at the Z max. Okay, that's all. Is it okay? So this is the setting for CFD analysis. You generate the mesh for CFD simulation, fluid simulation. And then you click close. So it's the same process. You click on full model button and we generate the mesh for you. Is it okay? You understand the joke? Yeah. You understand? You know why? You know why it's a image? You understand the process? Yeah, so it's exactly the same. So that's why we get it around the fork. Because around the fork is the egg. It generates the mesh of the egg. You want to see about the CFD software? Oh, okay. Basically it's more solid mesh. That's why so must be so do you know how to eliminate this?